Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about regular expression reluctant quantifiers. I'm going to open up my web browser to my website, javacjava.com, select menu and then Regex tutorials. I'm going to scroll down here to Regex reluctant quantifiers. Now there are three different groupings of quantifiers: greedy, reluctant, and possessive. This tutorial is all about reluctant quantifiers. Reluctant quantifiers are also commonly referred to as lazy quantifiers. Now in my Regex Greedy Quantifiers tutorial, we learned that greedy quantifiers instruct the matcher to match as many instances of its quantified token and return the largest possible string value. Now, reluctant quantifiers instruct the matcher to match each individual instance of a quantified token and return the smallest possible string value. Okay? Since reluctant quantifiers return the smallest possible value, you will often see that the matcher class find method will return true multiple times versus just a single time with a greedy quantifier. Okay? The syntax for reluctant quantifiers is the same as greedy quantifiers, only you will simply tack a question mark onto the greedy quantifier to turn it into a reluctant quantifier, right? So basically we have all the same syntax as the greedy ones, only we just tack a question mark onto it there, okay? So that's basically the way it works, and I'm not going to go over this again. Hopefully you watched my greedy quantifiers tutorial, because I'm going to recycle a lot of that stuff from there. I highly recommend you watch that before continuing, but anyway, we'll go ahead and move on here. So now the difference between the behavior of reluctant and greedy quantifiers in most cases is not obvious at all. Now the examples below are identical, only with the reluctant modifier added to the examples that I used in my greedy tutorial. And you can see that they will return the exact same results, right? So here we have color, C-O-L-O, right? And then the U, we're applying the reluctant quantifier there, which means once or not at all, right? That'll match color or color with the U, right? And so anyway, I won't go through all that again there, but the results are the same. You'll see that in the source code. We'll run that real quick and go over that. But the differences become apparent when you have repeating patterns inside of your search string. Now consider the following search string, right? Okay. And this is designed to be XML, and of course we wouldn't normally name these tags XML. They'd be named something like answer or I agree or whatever, you know. But anyway, so we got an opening XML tag here, and then we've got a value, and then a closing XML tag, and then just a little space in between there, and then an opening XML tag and a closing XML tag. Okay. So if we use the regular expression, this regular expression right here with the opening XML tag and closing XML tag, and then we use the dot wildcard there, right, and apply the greedy asterisk modifier, which means, of course, one or more times, right, that will return basically what it comes up here and it says, okay, I got my opening tag, all right, here's my first closing tag, but can I make a larger string than that? Do I have another closing? Oh, yes, I do. So I'm going to return back the largest possible return value, and that'll be the whole entire thing there with the opening tag and closing tag here. Now, if we use the regular expression and we apply the reluctant quantifier here to the wildcard there, right? Everything gets applied, paired up basically with its character or token to the left. So with doing this with the reluctant quantifier, that will basically say, it says, okay, all right, I'm starting out here and I've got my first match on that. All right, now we can have whatever we want. And then here's my next match, right? And I'm going to return back the smallest possible string. So this right here is going to be what I'll return back. So that'll return back this on the first call to the find method, and it will return back its next match for that regex pattern on the second one. Okay. All right. So let's go ahead and come down here to the source code. And I'm going to show you all kinds of stuff today, and some of it's going to be extremely confusing, but stick with me there, and I think you'll get it by the very end. So highlight all this, and we'll select Control C to copy, or right-click and select copy. I'm gonna move my browser off screen. I've got a shortcut to the command prompt on my desktop, but if you don't, create one really fast by right-clicking, selecting New Shortcut, CMD Next, and Finish. It's just that easy. Let's open it up. If you're new to my tutorials, type in Java C. That's the Java compiler command. You should see all this stuff scroll by. However, if you receive an error message, watch my tutorial on installing and configuring the Java Development Kit. You'll make sure that's done properly before continuing. CLS to clear the screen, CD space / CD is short for change directory, / tells it to go to the root. Now I'm going to go ahead and make a directory here called Java with the MD command, and I already have that folder, but if you don't, it'll go ahead and create one for you. And I'm going to call this one Regex Reluctant Quantifiers. Okay, let's change directories to that. Let's notepad up Regex Reluctant Quantifiers.java, right? It's the name of my source code file, also known as a compilation unit. All right, let's go ahead and paste all of our stuff in there and come up here and save this. All right, I have the exact same display find method here, static void display find, and actually it should start up here. Basically, I'm importing the Java util regex package. Single class, here's our main method entry point, and I also have another static method down here, display find. It does exactly what it does in the, it's just basically the same thing from the Greedy Quantifiers one there. So, and with that being said, let's go ahead and run a bunch of stuff through it. Now, what I've done is I've taken the exact same source code that was in the Greedy one, the Greedy Quantifier tutorial there, and I've added, basically the question mark, of course, the question mark, as I've said before, is the most versatile of all the meta characters in regex and can also be the most confusing. So, because it could be put in so many different places there. But anyway, so I've added the question mark to all the greedy quantifiers to turn them into reluctant ones there. So let's come up here and save this. Let's clear our screen. Let's compile it. And let's run it. All right, so right off the bat, let's come up here. And you can see that we've had the exact same matching results that we have over here too, right? Everything is the same. So it's really not readily apparent. Even we got the no matches for the color plus, right? And you remember the plus is one or more times, right? So, and of course, in this particular one where we just have COLORING, right? The U is not in there one or more times, so we get no matches found on that. But that's identical to the greedy quantifier. So running the XML example here, you can see that using the greedy quantifier version right here, we get back the whole entire thing, starting at this XML tag, going past the closing XML tag all the way over to there, right? So we get that whole entire value returned back to us in that particular case. Of course, once we apply the reluctant quantifier, it says I'm going to get the smallest possible return value out of this string right here. So it returns back, the yes value and then the no value. Okay, so it's basically the difference there. It becomes apparent there when we're doing that. But now let's, what I've done here is I've labeled this, here comes the confusion. All right, I've got basically the decimal 103 represented in binary here, right? Zeros and ones. So, and I just crafted this pattern so I could kind of demonstrate how the engine is working, and the engine seems to work contrary to some popular documentation out there, and I'll show you what I mean by that. But basically, I've crafted this as a 1 0, 2 1s, followed by 2 zeros and 3 1s. Okay. And all of our regular expressions are going to be based off of searching for the pattern number 1 and various different things there. So first off, with the question mark on the pattern number 1, right? And I'm doing it as greedy first, and then I'm demonstrating as reluctant second. So this means once or not at all. Okay, so what do we get for that particular one here? Well, let's go ahead and come down here to this section here. So the regular expression 1, and then the greedy quantifier for once or not at all, right? you'll see in the first result here, it returns nothing, right? And that's because that's gone with the not at all, right? Because the first character here is a 0, okay? So 1 is in there not at all, but it does return back true, right? Because once or, right? Or is the keyword there, or not at all. So in this first character, as it's starting to go through the string literal here, 1, well, it's in there not at all, so it returns back nothing, okay? So hopefully this makes sense. Now, when we come over to the next character here, right, it found number 1, you know, the second character here, so we return back number 1. And since we're doing once or not at all, this is the largest possible return it can come back in there, right? And then it finds the next one, right? And then in this next 0, it finds not at all. Then it finds not at all in the next one. And then you can see in the remaining 1, 1, 1, we get our 1, 1, 1. And now you'll notice down here, we got this straggler, right? We've got 1, 2, 3, 4, 5, 6, 7, 8 characters in our string literal, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, popular documentation out there will say that it actually, the way a greedy quantifier works is that it'll read the entire string first to check for a match, but this seems to say contrary, because the last thing it does is actually read the whole entire string, right? And that's it's a not at all match on the whole entire string there. Now, I can't say that 100% for sure, but you know, that's definitely the way it appears to me, because popular documentation says the first thing it does is read the whole entire string for a match, and then if it doesn't, it then backs out. But anyway, so but that's kind of irrelevant in this point, you know. I just want you to know that's the reason why there is in fact 9 results, return results there, right, on that particular one there. That's just something to be aware of, as you might be going, okay, well, 8 characters, the most possible return results should be 8, and that's not correct, it's 9. So applying the reluctant quantifier, guess what? We're still going to get 9 search results. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's obviously going through the same routine in the source code there, right? But our results are much different, right? And you'll notice that in all 9 of these results, we get back nothing. Zip, zilch, nada. And the reason why, and I'll explain this here, is I put in comments out here, greedy is largest possible match and reluctant is smallest possible match. Okay, so we come up here and we say, okay, the question mark, right, for a greedy quantifier means once or not at all, right? So for the reluctant one, it's the same thing, once or not at all. And it wants to return back the smallest possible match. So if you're going to return one thing versus 0 things, right? 0 is the smallest, so it's going to return back nothing. So as it's cycling through, it's doing the same sort of checks it does up here, only it's checking for 0, right? And it says, okay, I don't match that. That's easy, right? And then it's checking for 1, right? And it says, oh, I match that. But wait, hold on. Or we could have a not at all. And since not at all is the smallest possible return value, then it will say, I am going to return the not at all value. So if you're confused on that, then you're just going to have to trust me, and you know, it should hopefully make sense as I'll throw some more values in there. But anyway, yeah, as it's cruising through the string, 1, hey, 1 is a match, but not at all is less, right? Once or not at all, okay? All right, so it continues on through all 8 characters, and then it checks the whole entire string, and of course there's no match, so that's easy on that there, right? All right, now let's come down here to the next quantifier, which is the asterisk or star, and that's 0 or more times. So at this point in time, you might be going, oh, well, we might get some of the same results that we got up there, and the answer is yes. Okay, so now that before we had once, right, and now we're going to have more times, or more times. So the more times is 1, 2, 3, 4, all the way up to infinity. So what you'll notice on the first go through here, right? When we do 1 and we do the greedy quantifier star, is we get no return value, and that's because it's checking this first character, right? 0, right? So there's nothing there. Now the next thing it says is, oh, hey, I've got a match in 1, and I could do 1 or more. So go boop, boop, boop. Oh, there. We have to stop here. So this is the largest possible return value there. The next one it checks there is this 0, right? And that doesn't match, so it returns back no find. And the reason why it returns back no find is because we got 0 or more times. So in this particular case, 0 is the largest possible match that the greedy quantifier can return back right here, okay? Same thing here too as well. 0 is the largest possible match. Then we get that, now we're over here to the last 3 1s, okay? And it'll return 1, 1, 1 because that's the largest possible match it can return at that point. And then the final thing it'll do is it'll take the whole entire string there, and that doesn't match, so it'll return back 0 possible matches, right? 0 or more times. Okay, now when we apply the reluctant quantifier to that, of course we get absolutely nothing returned back, and that's because 0 is always the smallest out of or more times, right? So 0 is always less than 1 up to infinity, so it's always going to return back the smallest possible match, which is an empty string, okay? All right, so now let's go ahead and take a look at the plus quantifier, which is 1 or more times. So now let's just take a look at this here. So the greedy quantifier for 1 plus will return back 1, 1, which is the first instance of these 1, 1s until it hits a 0, which is the largest possible one that it can do there. And then 1 plus will return back 1, 1, 1 as it's cycling through the string right here, okay? And it cycles exactly the same way through there. Now we apply the quantifier to there, and the way this works is it goes through and 0 return back false because we, of course, are looking for 1 or more, right? So then it finds this first number 1 and it says, oh, okay, I want the smallest possible return value, so I'm just going to return back 1. I'm not going to go over and grab this next one because that would be making a large one. That's what the greedy guy did up here, right? But I just want the smallest one returned back. So then on the next one down here, it says, okay, here's my next one, right? And then there's a couple zeros in between here that don't return back true at all, or no, for the find anyway. And then basically it finds the next one and the next one and the next one, right? And then of course it does the whole entire thing, which doesn't match at all anyway, so it's not even, doesn't even return back any sort of value because we of course are reiterating this 1 or more times, okay? So that's what's going on right there. It'll find all 5 of those ones and it'll return them back the smallest possible match, okay? All right, now let's go on and do some greedy quantifiers here. And basically on this particular one here, we'll just do this one here, right? We'll just basically specify exactly, right? This is the exactly x times here, okay? So if we do exactly 2 times, with this, the greedy quantifier for that is going to return back these 2 and then these 2 right here, okay? And then that's it, right? Because exactly 2 times, even though, you know, a greedy quantifier really wants to return back 3, but it can't because these 2. So basically our results are identical when we use an exact match on that, right? Because the largest possible on exact is going to be the same as the smallest possible on exact. All right, now when we specify the quantifier that says at least x times here, so we just add 2 comma and blank, the greedy quantifier will find this one first and return back 1, 1, and then 2 basically or more, it'll find this guy, says, all right, I can give back more. All right, I want to do that, right? Okay. Now we apply the reluctant one here. It finds this 1, 1 right here, and that's our minimum that we can return back is 2, so it's our smallest possible one. And then it finds, you know, 1, 1, 1 basically is the 2 or less, but what's the smallest possible string in this particular one here where we have to have a minimum of 2 characters, right? It returns back 2 out of the 3 characters, okay? So that's the smallest possible there. All right, What did I do? Did I do 2, 3? All right, I think I've got a little typo in my, yeah, I wanted to do this here, 2, 3. All right, let's save this here. I have to fix that typo there because basically last one I want to do was basically the range, at least x but not more than y times. So let's go ahead and come up here and recompile this. Get that off the screen there, clean that up. Okay, so our 2, 3, right? That returns back, well, we can enter anywhere from 2 to 3, right? So it finds the first 2, then it finds the last 3 here, right? And same thing here, right? It finds the first 2, and then 2 with a maximum of 3. What's the smallest possible return string for the reluctant quantifier here? Well, it's just the 2 digits. Okay. All right, so hopefully that all makes sense there. And now if you come back up to this first one right here, right, where we're returning the smallest possible value out of everything, right? Even though there is a 1 here in the second find right here, since the question mark indicates once or not at all, it's going to go with the not at all for the smallest possible string value. So hopefully all that makes sense there too. Same thing with the asterisk, which is 0 or more times. Okay. So I'm just going to kind of leave you on the final note there by going back into one of my examples from the greedy quantifiers there. So we've got this string literal here. I like happy large dogs and happy small dogs. Well, we've got repeating pattern between happy and dogs, right? One's happy large dogs, the other's happy small dogs. So of course the greedy quantifier here applied to the wild card in between happy and dogs will return back the largest possible. Even though it hits this dogs right here, it can go all the way out here and give us the largest possible return value, which it in fact does, right? It found happy large dogs and happy small dogs in that string literal. Applying the quantifier modifier there, the question mark, to that, reluctant modifier to the quantifier there, finds happy large dogs for the first find, because that's the smallest possible string, and then happy small dogs for the second one, okay? So anyway, I'm going to go ahead and get rid of that, and just leave you guys with some final thoughts there. So at this point, if you're experiencing confusion or frustration, you may want to wait a day, then watch it again. Sometimes new concepts take some time to sink in, but just know that you're learning if you're confused or frustrated. So, but otherwise, stay tuned for my next tutorial where I'll demonstrate possessive quantifiers and show you how they behave differently from both greedy and reluctant ones. That concludes this tutorial. Thanks for watching.